Hello, I'm Swati Srikumar, and this lesson 3, is on significant figures. Now, what does one mean by significant figures? The result of measurements should be reported in a way that indicates the precision of measurement. And so, normally, the reported result of measurement is a number that includes all digits in that number that are known reliably plus the first digit that is uncertain. So, we can say that significant figures are the reliable digits plus the first uncertain digit in a reported result. For example, if the measurement is 1.62 seconds, then 1 and 6 are the reliable and certain digits, and 2 is the uncertain digit. This measurement thus has three significant figures, which are 1, 6 and 2. How is significant figures useful? Well, as we said earlier, it indicates the precision of measurement of which depends on the least count of the measuring instrument. Now, what are the rules for determining the number of significant figures? All non-zero digits are significant. Here, 1, 2, 5 and 7. 1, 2, 5 and 7 are significant. All the zeros between two non-zero digits are significant, no matter where the decimal point is. So here, this 0 in between 8 and 5 is significant. So this number has 1, 2, 3, 4 significant figures. Now, if the number is less than 1, the zeros on the right of the decimal point but to the left of the first non-zero digit are not significant. That is, here the first three zeros are not significant, whereas the 0 in between 3 and 8 is significant. So this number has 2, 3 and 0, 8. These four numbers which are significant. Now, the next rule is that the terminal or trailing zeros in a number without a decimal point are not significant. That is, 1, 2, 3. Only three numbers are significant. Because here you can see that 123 meter can be written as 12,300 centimeter, and so two zeros are added here. Thus, if these zeros were counted, then the significant figures would have changed. And so we say that the trailing zeros are not considered as significant figures unless there is a decimal point. Now, the trailing zeros in a number with a decimal point are significant. This is exactly what we talked about here. If there is a decimal point, then the zeros will be considered to be significant. Moving on, what are the best way to report measurements? To remove ambiguities in determining the number of significant figures, the best way is to report every measurement in scientific notation, that is in the power of 10. Now here we can see that a number is expressed as a into 10 raised to b. That is, any measurement that you get, you can express it as a number a, which is a number between 1 to 10 into 10 raised to a power b, which b could be positive or negative exponent, and this is also called as the order of magnitude. of any physical quantity. Example is this. Here minus 8 is the exponent or the order of magnitude. Moving on, the rules for arithmetic operations with significant figures. For multiplication and division, the result should have as many significant figures as there are in original numbers with the least significant figures. That is, in this example, for density, the mass is 4.237 gram and the volume is 2.51 centimeter cube. Now when you divide these to get the density, you will notice that the volume has 3 significant figures and the mass has 4. So the result should have the least significant figures of the original values. That is, here the volume has the least significant figures, which is 3, and so the result density should have 3 significant figures. Now for addition and subtraction, the result should have as many decimal places as in the number with the least decimal places. For example, if these two measurements are subtracted, you'll notice that both of them have 3 decimal places. So, as you get the result as 0.003 meter, you can write this as 3 into 10 raised to minus 3 meter. Here minus 3 is the order of magnitude, and so the significant numbers will be 3. Now rounding off. How do we round off a number to a particular number of digits? The preceding digit is raised by 1 if the insignificant digit is to be dropped is more than 5. That is, if you have a number which has the last number to be more than 5, then the number which is just before the last number, the penultimate digit, is raised by 1. That is, if the value is 2.746, here we see that 6 is greater than 5, and so the penultimate number, which is 4, will be moved up by 1 number, and so it becomes 5. And if the penultimate number is less than 5, if the last number is less than 5, then the penultimate number or digit is left unchanged. That is, if it was 2.745 instead of 6, then it would have been 2.74. The digit 4 would not have been changed. Now, if this insignificant digit is 5, what would we do? What has to be done is that the penultimate digit, if it is even, then there will be no change. But if it is odd, then it is raised by 1. That is, in this example, 2.745. If you round off to a number with 3 significant figures, you will have 2.74, as this 5 is here and the penultimate number is 4, which is even, and so as we saw here, it is left as such, that is 2.74. there is no change to the digit 4. Now if it is odd, that is in this case 2.735. It is 3, which is odd, so it is 1 is added to 3 and we get the number 2.74. So I hope rounding off and significant figures, how to calculate them, is clear after this lesson. Thank you. And the next lesson will be about experimental methods and the least count of the instruments. Thank you once again.